All right, sample problem 5.6 says a steel tank has a volume of 438 liters and is filled with 0.885 kilograms of O2. Calculate the pressure of O2 at 21 degrees C. All right, so remember our equation. We have PV equals nRT. And then if things are changing, right, we have P1 V1 over N1 R T1 is equal to P2 V2 over N2 R T2. So there's our two equations we have. And let's see. Is anything changing? No, they didn't say anything about anything changing, so that means I'm going to be okay to use PV equals nRT. And so let me write that one down. PV equals nRT. And they're asking for a pressure, so I've got to get pressure by itself, right? I've got to get this guy by himself. So P is going to equal nRT divided by V. So N is the number of moles, R is the gas constant, T is the temperature, V is the volume. So here we have it, right? Now, what information have they given me? They've given me a volume. I'm going to write V equals 438 liters. They've given me a mass. I've got 0.885 kilograms of O2. They've given me a temperature. T is equal to 21 degrees C. And I know what R is. They didn't tell me this, but R is a constant, right? It's 0.0826 liters times atmospheres divided by moles times Kelvin. So I've got all my stuff here. Now I just have to figure out how can I put it into PV equals nRT. They didn't tell me N, right, the number of moles, but they did give me a mass. So let me start with that. 0.885 kilograms of O2. I can convert that mass to moles by using the molar mass, right? Because the molar mass of O2 is just 2 times the molar mass of oxygen, which would be 32 grams per mole. Note, that's grams per mole, though, and here we have kilograms. So I've got to first say that in 1 kilogram there are 1,000 grams. And now I can use that molar mass, right? There's 32 grams of O2 in 1 mole of O2. And so now I'm going to have the moles. So let's do this math real quick. And I got 27.7 moles of O2. Okay, so P is then going to equal 27.7 moles of O2 times R, which is 0.0826 liters times atmospheres divided by moles times Kelvin, times T. Now, our temperature they gave us is in degrees C, so remember we have to convert that to Kelvin by adding 273.15. So that's going to be equal to 294.15 Kelvin. So let me plug that in here. Divided by V. Now, what units should my volume be? Well, let's talk about that. R has units of volume in liters, so my volume should be in liters, and it already is, so I don't have to convert that one. I can leave it in liters. So 438 liters. Now let's check our units first. Check it out. I've got moles divided by moles. They cancel. I've got liters in the top with R, liters in the bottom. They cancel. I've got Kelvin in the bottom of the units for R and Kelvin up top with the units for the temperature. They cancel. I'm going to be left in with just those atmospheres, right, which are units for pressure, and that's a good thing because I'm supposed to be calculating the pressure here. So now I can do my math. 27.7 times R, which is 0.0826, times 294.15 divided by 438 equals 1.54 atmospheres.